Previously on Second Earth Alternative.
To have the sides of the pyramid actually go up 47 stories and meet in such a perfect accuracy so as to fit a capstone, you would actually have to take into account Earth's curvature at its foundation. If it wasn't the Egyptians, then who would it be? Little green man? It comes out to 3.1605. Why is it that a book that was written 1,000 years after the Great Pyramid of Giza was constructed would have a pi value that was close to 10 times less accurate? So if you to take the side divided by the height of the pyramid, 1.272, the square root of the golden ratio. Take the height of the pyramid and then divide it by half of the base, 1.272, the square root of the golden ratio. Take the base and divide it by the side, 440 divided by 356.089 cubits, that equals 1.2356. The quarter distance of Earth's circumference, exactly 1.2356. But that's basically a section of the Great Pyramid of Giza. Take that number and divide it by the distance of Nazca in Egypt, the golden ratio. The distance from the pyramid in Mexico to the pyramid in Giza happens to be the same distance as the Pyramid of Giza to the Nazca Plateau. Let's say we start at the Easter Island with those mysterious statues that are looking into the sky. That line would then cross the Paracas Chandelier, the Nazca lines, then we would actually hit Machu Picchu, the Giza Plateau, city of Petra in Jordan, city of Ur in Iraq with strange reptilian statues, goes through Persepolis, Iran, Angkor Wat in Cambodia, and it might explain why there was a common motif with the pyramids with almost every culture of the world. Maybe, just maybe, Atlantis was actually in Africa. The Eye of the Sahara is also in the boundary of that line.
Welcome to Second Earth Alternative. We have an absolutely incredible episode today. Now, as you noticed from the intro, in our previous episode, we had unveiled some unbelievable facts, some world alignments. We're talking about the Egyptians knowing pi way more accurate than they had written in their mathematical books 1,000 years later. And the question really is very simple. Is it possible that the Egyptians could have really built the Great Pyramid of Giza? So today I wanted to re-examine that question, but give you some even more remarkable facts. I'm going to advise you to strap on your hairpiece because this episode is going to blow your mind away. So it's not just the fact that the Egyptians had built the pyramid in such a manner that it actually was, in a way, an image of Earth, as if they actually knew the dimensions of Earth itself. That's something we'll be going over today. But most striking is the idea that the Egyptians may have actually encoded the speed of light in their pyramids, not just in one way, but in two separate ways. I kid you not. We're going to be showing you how all of this can be decoded, Dan Brown style. And just to kind of give you a preview, something that I forgot to mention in the last episode, the Egyptians had built this amazing monument. And we had talked about all the stones that they had built and the amazing accuracy, but something that we forgot to mention was the fact that the king's chamber was made from granite blocks. Now, some of these blocks weighed over 60 tons and were brought over 600 miles away. So you gotta imagine, how would you transport 60-ton blocks and then actually lift them, I don't know, God knows how many stories, 20, 30 stories perhaps. But the idea that these blocks were supposedly carved in this machine-cut mannerism with chisels of copper and bronze, which is what the Egyptians were said to have had at the moment. But just that fact alone already flies in the face of logic, because granite is a lot more dense than either copper or bronze. So it's one thing to even be able to carve granite, let alone carve it with this type of accuracy. So without further ado, I want to show you how the Great Pyramid of Giza encodes the speed of light. Take a look.
All right, ladies and gentlemen, so in this particular case, we're going to have to do a little bit of mathematics, but I'll go ahead and kind of go through this as simply and as easy as I can, and I think the results will make it all worthwhile. So the big claim here is that the difference of the perimeter, or I should say the circumference of the big circle to the small circle equals the speed of light. Now, what do I mean by big circle minus the small circle? Well, we're talking about the circles that you can create from the Great Pyramid of Giza. So let's say that this right here is the pyramid, and essentially you can create a circle on the outside where the ends of the pyramid is touching the circle, but you can also create a circle in the inside. So in order to be able to verify this claim that the circumference of the big circle minus the small circle equals the speed of light, we're going to have to find some values. Specifically, we're going to have to find the radius of the big circle and the small circle. So what we do know is that the base of the pyramid is 230.34 meters. That's a given based on the measurements that you can look up on Wikipedia, for example. And so what I'm going to use is the Pythagorean theorem, because I want to find the radius of the big circle, which would be this guy right here. And in order to do so, I have to find what the full diagonal is. So I can find this full diagonal if I simply go a squared, b squared, and then call this c squared. So since this is a right angle, we're going to go ahead and use the Pythagorean theorem, a squared plus b squared equals c squared. And that would essentially be 230.34 meters squared plus 230.34 meters squared equals c squared. So 230.34 squared is this value, 53,056.5156, multiplied by 2, since it's happening twice. That's going to give us the diagonal. So given the fact that we actually are not looking for the full length of the line, but we're actually looking for half of it because we're only needing the radius, if you take the square root of 106,113, we get the diagonal of 325.749952, and then we're going to have to divide it by 2 to get the radius of the big circle, which equals 162.874976. You can go ahead and check my math if you like. And we're also going to need the radius of the small circle. Now this one's a lot easier because this right here would be the radius of the small circle. And that's really only, look at this, it's just half of the base. So we know the base is already 230.34 meters. So we divide that by 2 and we get 115.17. Now, what I'm doing here is I'm putting these values that we just got, the big radius and the small radius, I'm placing them in the 2 pi r circumference formula. So, in order to get the difference of the circumference, we basically have 2 pi times the radius of the big circle minus 2 pi times the radius of the small circle, which comes out to 2 pi times 47.704976, since we're just extracting the 2 pi from both sides. And that ends up equaling 299.739204. So there's our answer. And what is the actual speed of light? Write it real quick, speed of light. That equals 299, let's put a decimal point there, 792.458 meters per second E6, which is basically 10 powered by 6. So I'm just mostly concerned about this value and how close it is to this value. Well, truth be told, it's incredibly accurate if you take a look. In fact, it's actually 99.99% accurate. I'm going to spare you the math. You can double check me if you want to, but that's really how accurate the answer is. So I think the claim that the big circumference of the pyramid minus the small circumference from the 2 circles that can be created from the pyramid, I think that claim has been validated to a certain extent. But then I started wondering, what happens if it's 100% accurate? How would we find the exact base length in meters that would give us an 100% accurate rate for the speed of light? So this is a little bit trickier, but what I did is I referenced everything on the base. So I'm calling these sides the base, and in order to find the radius of the big circle, which would be this one, well, we have to put it through the Pythagorean theorem. So what we did in the Pythagorean theorem, if you remember, is we had to square the value, and then since the value was repeating, let me show you real quick. It was repeating 2 times, well, that would be 2 times b squared, and then eventually we would have to take the square root of the value because it's c squared on the other end, and then divided by 2 because really we're just looking for the radius. So in order to get the circumference of the big circle according to the base of the pyramid, this would be the formula. So this is the formula for the radius of the big circle times 2 pi to give you the full circumference, minus the radius of the small circle, which is really just, if you remember, it's just the base divided by 2 times 2 pi. So essentially I'm trying to create a formula here to see what value equals the speed of light. So if you're to simplify this formula, well, the 2's cancel out, and then you can extract the pi from both values. So then you get pi times the square root of 2b squared minus b. Well, the base squared, since it's inside the square root, well, we can take that out as well. So we get pi times b times the square root of 2 minus b. Well, we can extract b as well. So then that's really, the circumference difference is going to equal pi times the base times the square root of 2 minus 1. The formula simplifies pretty nicely in the end. So all we have to do now is plug in the speed of light for the circumference difference. So that would equal, as we have it over here, 299.792458 would equal pi times base times the square root of 2 minus 1. And let's just go ahead and plug in those values real quick so we can verify the math. So I got my little scientific calculator over here. So we're going to take 299.792458 divided by pi times the square root of 2 minus 1. And that gives us a value of 230 meters. Actually, I already wrote it down here. 230 meters, 0.38092339. So that's the exact length that the Pyramid of Giza would have to be for us to get a perfect, and I mean perfect, speed of light value for the difference in the circumference. Well, what's so interesting about that value is that we know that the base is 440 cubits. You know, I mean, that's what they tell us. It's literally written in the Egyptian text. So we can actually figure out a cubit value given this meters. So our cubit value would be 230.38092339 divided by 440, which equals 0.5235930089. So that is our cubit per meter value. But here's what's so interesting. If we were to convert that into inches, right? So let's take a little conversion tool. And we got how many cubits? 0.5235930089. Well, that gives us 20.613 inches. Now, the big question is that a possible value? Could the cubit actually equal 20.6138 inches, which would essentially give us the perfect value of the speed of light? Well, check this out. They claim it's 20.64, but that's actually not the answer. The answer is that it's anything. This is actually an academic paper here, if you take a look. It talks about the whole history of the cubits. And what they're stating is that the cubit value is not really known, but it's estimated to be somewhere between 20.6 and 20.64. What do we have? 20.613, which is a little bit in the lower bounds of what is close to the average between the two values. So yes, ladies and gentlemen, there is a qubit value that falls within the range of what is possible that would give us the exact length for the speed of light. I mean, this is unbelievable. Now, I hope I didn't lose you with all that math, because the next one is a lot more interesting, a lot more fun, and I want you, ladies and gentlemen, to participate with me in this one, because this one is gonna absolutely blow your mind. So I want you to go ahead and open your Google Earth right now. And all I'm gonna do is I'm gonna give you the value of the longitude. So all I want you to do is plug in the longitude, which is 31 degrees, 8 minutes, and 3.82 seconds east. And put a comma in the middle, because what we're gonna do at this moment is we're gonna look for the speed of light. And I'm not kidding, this is pretty amazing. So if you're to take any conversion tool, right? So in this particular case, I'm using earthpoint.us. And I'm gonna go ahead and plug in the speed of light for the latitude, and let's see what we get as a conversion. So we need to get the speed of light here real quick. If you recall, the speed of light is, in this case, would be 29.9792458. We're placing the exact numbers that are equivalent to the speed of light. I mean, we know that the Pyramid of Giza is in the northern hemisphere, so we'll just put north. And then longitude, this could be whatever. We already have our longitude. Just put 1 if you'd like, just so that this thing will calculate. Press calculate. And your latitude is converted right down here in this degrees, minutes, second conversion. So go ahead and copy that. And we're gonna go back to Google Earth. I want you to place that for the latitude. Make sure you push N for north. And I'm gonna give you a second because I want you to go ahead and try this yourself and see what happens. All right, so let's do it. Ladies and gentlemen, that is not a joke. Basically, when you plug in the speed of light for the northern latitude, there is only one place in the entire northern hemisphere that is going to have that exact value, that exact speed of light value. And it happens to be directly over the Great Pyramid of Giza. Why not Khafre's pyramid or maybe the Sphinx? The fact that it's not only in the Giza plateau, but literally right over the center of the Great Pyramid of Giza, I mean, could this be just a coincidence? That in two different ways, we are able to extract the speed of light from the dimensions of the Pyramid of Giza and by plugging the speed of light as a coordinate? Now, you might think that the coordinates are meaningless for the Egyptians, but that's not true. The coordinates were actually created off a system which came from the Egyptians. So there you go, ladies and gentlemen. If you're not shocked by this, well, please stay tuned because we got a whole lot more.
Now, me personally, when I actually looked into this and started mathematically trying to back this up, my jaws were basically open the whole time. I was just like, are you kidding me? Like, how is this so verifiable, so real, but it's not ever talked about by academics or scholars? You know, it kind of reminds me of the concepts of UFOs. You know, are they just scared to face the truth? Because numbers, they don't lie. Numbers are numbers. Mathematics is mathematics, and these numbers are there regardless of my ideas or my theories or my opinions. But another fact that is actually quite remarkable is the idea that the Great Pyramid of Giza actually lies in the center mass of this planet. In talking about the world alignments, I wanted to start out with this. And what I mean by this is that the actual Great Pyramid of Giza, if you were to take the cardinal points, north, south, east, west, and the corners, well, all those cardinal points, if they were to expand away from the Great Pyramid of Giza, it would actually go over more landmass than any other place in the entire world. Now, is this just a coincidence? Well, I think not, and I'm going to show you why. So I have my cheat sheets once again. First, what I want to do is talk about the perimeter of the Great Pyramid of Giza. Now, we did the same thing with our previous episode in talking about pi, but in this particular case, I want to talk about how this relates to Earth itself. So some of this information and actually some of the exact measurements that I'm getting came from a researcher named Randall Carlson. Now, he doesn't believe that it was quote unquote UFOs or aliens, whereas this channel thinks it's feasible, it's possible that there was some kind of extraterrestrial influence. So I don't want to speak on his behalf, but I do want to link his information because some of his research is extremely relevant. So here's the thing about the Great Pyramid of Giza. It actually has two perimeters. Most people may not be aware, but there is actually the perimeter that is composed of the actual pyramid itself. But underneath the pyramid, it's almost like a foundation, there's something that's called the socle. And these are blocks that are not necessarily curving up like the pyramids do, but kind of stand as like a base foundation. Now, the interesting thing is the Great Pyramid of Giza is not perfectly symmetrical. I mean, it's very close. So I'm just gonna put up the measurements right there. And what's most relevant about this is the perimeter of the Great Pyramid of Giza, which stands at 3,023.139 feet. Now, if you were to take into account the socle, the actual foundation underneath the pyramid, well, that perimeter increases a little bit. It actually becomes 3,043.433 feet. Now, why is this important? Well, remember how I just told you that the Pyramid of Giza lies in the center mass of the Earth? Let's say that you actually start at the center of Earth, meaning the 0-degree latitude, the very equator. And let's say that you were to draw one exact degree. Now remember that the Earth is separated by longitudinal and latitude lines. And wherever those lines cross each other, they create little blocks all around the world. Now, each one of those blocks is a single degree of measurement. And I just want to say ahead of time that these numbers are not arbitrary.
Yeah, maybe we could just get together and eat a bunch of caramels.
What do you mean?
When you think about it, it's as arbitrary as drinking coffee.
The actual degrees and the way that the Earth is split in regards to the coordinates, well, that system actually comes from a system that was adopted from the Egyptians, a number system based on the number 60. And I should also say that our time, 60 minutes, 60 seconds, is also adopted from the Egyptians. So anytime we talk about time or the coordinates, just remember that these numbers actually have relevance to this particular culture that we're referring to. So if we were to take 1 degree from the center of the Earth, from the very equator, well, let's just go ahead and convert it right here. We have a little converter in the back. And that tells us that the latitude is composed of 362,775.76 feet, and the longitude is composed of 365,220.59 feet. Now, what's so interesting about this is that whereas we have entire degree with that single box, within that box, you also have the minutes and seconds as well. I mean, think about how you write coordinates for Google Earth. And a minute, just like you would assume like a clock is, it's composed of 60 segments of that 1 degree. So 1 minute for the latitude would be 6,046.2627 feet, and the longitude would be 6,087.0098 feet. Now here's where things get really, really interesting. If we were to take 1 minute, one of those 60 boxes that can fit in that 1 degree, well, let's split that box in a quarter. So you have 4 boxes within that 1 minute. If you can split that box into a quarter, Well, check out the dimensions of those boxes. Well, that would essentially be 1 minute divided by 2, as you can see in the graph, which would mean that the latitude is 3,023.13 feet, and the longitude would be composed of 3,043.50 feet. Do those numbers look familiar to you? Take a look at the perimeter of the Great Pyramid of Giza. And if you're wondering why the latitude and the longitude are different sizes, well, that's because the Earth is not a perfect sphere. It's kind of oblong shaped due to the tidal forces of its spinning on itself. But somehow, the Egyptians, by building the circle around the pyramid and creating 2 different perimeters, it seems as if they're actually indicating this, as if they actually knew the Earth's dimensions. Because another way of thinking about it is that in a single minute, that 1/60th of a degree, well, you can fit 16 Great Pyramids perfectly in that box. How is this possible? I mean, this is like, it's not even the fact that they knew the actual length of the Earth, it's the fact that they knew that the Earth was asymmetrical. I mean, this type of knowledge, okay, yeah, do your little chiseling with the copper and the bronze. I believe that makes a lot of sense. Now, I thought that was one of the craziest things I've ever seen regarding the pyramids, but then there is this, which I'm about to share. And look, I don't know how to even start this. Maybe talk about the cosmic order of the universe, maybe talk about the sun, the moon, the fact that the moon is the same size as the sun from our perspective. Is this all in order? Was something created by some kind of ancient aliens? I don't know. I mean, whatever created all of this, all these coincidences that I'm about to reveal, I've honestly, from my personal opinion, have come to conclude that somehow we, just like the Egyptians might have inherited the pyramids, I believe we inherited a solar system that was a lot more organized, a lot more ordered than a lot of the skeptics like to admit. And let me show you what I'm talking about. How many seconds is there in half a day? Well, it's 43,200 seconds. How many minutes is an entire month, which is 30 days typically, at least if you count the way the Sumerians interpreted a year of being 360 days, with 5 added days because of apparently a comet strike that might have actually spun the axis of Earth a little bit faster. So, not my word, these are just what some of the legends are saying. But I ask again, how many minutes are in an entire month? Well, it's the same amount as there are seconds in half a day, which is 43,200. Now, if we were to take half of the diameter of the sun, just like we're talking about half of a day, well, the radius of the sun, according to the NASA page, you can take a look at it yourself, well, it says it's 432,169 miles. So you're telling me that the radius of the sun is only 169 miles away from the exact number of 43200? I mean, yeah, you have another 0 in the end, but are you kidding me? Is that coincidence? And that's why I started talking about the cosmic order, because then I remember the moon being the same size as the sun from our perspective. It's not even the fact that we have a perfect solar eclipse, unlike any other planets in the solar system. It's also this strange coincidence that we are the only planet in the solar system that we know of that has intelligent life. So the only planet that has intelligent life, that is building spacecrafts that can eventually go to Mars, just happens to have this perfect solar eclipse, almost like a cosmic clock. Is that just coincidence? And then I started thinking about the moon, which has a radius of 10,080 miles. Now remember how we had to divide a minute by 4 to get dimensions to match the exact perimeter of the pyramid itself. Well, what is 1080 times 4? 4,320. I mean, I literally have goosebumps as I'm reading this to you. And here, ladies and gentlemen, is the big clincher. The height of the pyramid is 480.953 feet. The socle is 21.6535 inches. You add those together, you get a total height of 482.7575 feet. So I'm gonna ask right now, how many pyramids would you have to stack up to get from the equator to the North Pole? Essentially the polar radius of Earth. How many pyramids would you have to put together? It's actually quite an easy equation. The polar radius of Earth is 20,855,485 feet. This is according to the NASA websites. Now take that number and divide it by 482.7575 feet. And ladies and gentlemen, you would have to stack up 43,203 of a pyramid. I kid you not. 43200. I'm done. This is like, what, are you kidding me? If you don't believe in aliens, that's okay. All power to you. Everybody's entitled to their own belief. Was it a more advanced civilization than the Egyptians? Maybe a Atlantean culture, somebody who we don't even know about, somebody who had knowledge that we're not currently recognizing? My opinion is that is almost a certainty. Of course, we have our own reasons for believing in the cosmic connections and the possibilities of intervention, which we have addressed in multifarious different ways. But the fact still remains, people with little bronze and copper chisels, they're not going to create that. That's just as clear as daylight. Now, ladies and gentlemen, I want to give you a big thank you because the very first episode, we had a tremendous amount of support. A lot of people ended up liking the video. And unfortunately, we still broke under 1,000 views. And this has nothing to do with the audience. It just has to do with kind of this channel, unfortunately, might be a little bit repressed. Now, YouTube told us that the golden ratio, no pun intended, I mean the golden mark for likes to views is 20. And we actually almost breached that in that first part of the episode. So as a goal, and if you enjoyed this episode and you really wanted to kind of help us out, let's see if we can actually break that goal. Let's see if we can actually break over 20% like ratio. And that would be really kind of interesting to see, because it would be like breaching YouTube's golden mark. And then if this video doesn't get over 1,000 views, it's kind of like, okay, we know what's going on. Anyways, if you have not subscribed, please subscribe. And as always, thank you so much for joining me. This is Felipe speaking, signing out.